Math doesn't care how smart you are. It only cares if you're willing to try, fail, and try again. Math doesn't care how smart you are. It only cares if you're willing to try, fail, and try again. That's why it feels impossible until it isn't. Suppose we're given a problem of the integral of x squared ln x dx. How are we going to integrate this? Like a child, you try every single method on your hands. You try the use substitution method. You take the derivative of ln x. It's 1 over x. Doesn't fully cancel out. Then you try a new method called integration by parts, where here the equation for it is given, where it says that if your integral is in this form, where u times the derivative of v, it should equal to this expression right over here. All right, we'll call u ln x, and then we'll call dv over dx x squared. They're just multiplication of signs, so we can just switch their places, and it's still going to be in this form. Then what do? We try to achieve v, because we got v in this equation right over here. And to achieve v, we simply integrate both sides. Here we have v. By using the power rule for integration, we simply do x cubed divided by 3. Next step here, we find du over dx, because we're going to use this in our equation. So du over dx is simply going to be the derivative of u. So du over dx, and the derivative of ln x is simply 1 over x. Now that we got all the variables that we're going to use in the equation, we simply have to just plug them in. So our integral becomes u times v, where u is ln x, times v x cubed over 3 minus the integral of v, which is x cubed over 3, times du over dx, which is going to be 1 over x dx. If we simplify, it's going to be x cubed over 3 ln x minus the x's cancel out here, becomes x squared. We have 1 over 3, we take the constant out of the integral, and we have x squared dx. So here we just do the final touches, x cubed over 3 ln x minus, now this is going to be x cubed over 3, the integral, so it's going to be x cubed multiplied by 1 over 3 over 9, then plus constant c. I could have took ln x as dv over dx, but then when I integrate, I'd see I cannot integrate ln x. I'd have to use integration by parts again and again. And so you try and you try and you try again. In the end, you're gonna get the answer that you need.